Okay, so we're continuing our testing tips or testing 2 lectures. I think I just call it testing 2 in the schedule. But today we're talking about my favorite topic, the debugger. Woo, baby. So the debugger, I did my pitch for it earlier, but I'll do it again here, is I think one of the biggest time-saving tools that we have available to us as programmers. I've saved countless hours by being able to use this. When I first learned how to use the debugger, I had the epiphany of how did I ever live without this. It's an extremely powerful tool that can help you find all the bugs ever. And after today's lecture, it's one of the things that I'll probably bring up a lot in office hours. When you have a bug, especially when it's clearly like just sloppy coding, that kind of bug, where your test cases are failing especially, I'll say, what's the debugger say? And then usually I watch a student fumble around and go, oh, wait, what's the debugger again? And I say, did you show up to lecture? Like, what the hell? And usually the answer is no, but they won't admit that. So none of you will be these people, but the debugger will save your time. This isn't a lecture that I do because, I need you to know this stuff or whatever, but this is something that's going to save your time and get you through the assignments a lot faster, so you don't have to pull all-nighters and spend 40 hours on a single assignment. We don't want that. Nobody wants to do that. I don't want to see students doing that. I don't want to see that. Find your bugs with the debugger. So with that sales pitch, let's get into it and talk about how to use the thing. Before that, let's bring back some code. What I have here, and the debugger, it's made to debug. We're trying to find and eradicate bugs. That's what we're doing with this thing. So we better have some bugs. So I have some broken code here that's broken in, I don't know, not too obvious ways, but this one, a lot of you will probably spot the bugs without the debugger. The next one will be a little trickier. But we're going to revisit this grade code where we have this grading structure in a percentage-based grading course, and we want to return these strings based on these inputs. So 97 to 100 is an A+. Anything over 100 or under 0, return the string invalid grade, and then all these other grades following, when we had this example before, following that same structure. When we did that example before, I kind of off the cuff said, oh, this code can give an F- or an F+. We're going to fix that. Those are bugs. We don't like that. So I showed buggy code earlier, so we can debug it now. And I'm creating our compute grade method. This part we didn't have before, but I want to call the 2 methods that we already created. The letter method, which gets the letter grade for a score, computes A, B, C, D, E, or F, and the plus minus method, which is going to return empty string plus or minus for the modifier to add to that score. So for these, we're going to get the tens digit, so score integer division by 10. That'll give us just the tens digit, or if this is exactly 100, it's going to give us 10, but we're going to handle that right in this first conditional. If the score is less than, or actually, no, we're not, less than or equal to 100, and greater than or equal to 0, so if it's not an invalid grade, then we're going to run this logic. If it is an invalid grade, I'm taking advantage of my initial value for this letter grade variable. This is something I end up doing a lot. I don't know if it's the best way to code or not. I like doing it, though. Is I'm going to initialize my variable to some default value. That's going to be the value that's returned if none of my conditionals hit. So if none of my conditionals hit, which will be this one, if this one doesn't hit, I'm just going to return letter grade and return whatever the default value is, which is what I want to be returned. If it's greater than 100 or less than 0, I want invalid grade to be returned. So I just set that as the default value, is the initial value. If it is a valid grade, we're going to compute, is it an A, a B, a C, a D? If it's none of those, it's going to be an F. Then our plus minus code, we're going to do the same thing, an initializer of empty string. So if none of our conditions hit, we're just going to return empty string. If this is a valid grade, if it's an invalid grade, just return empty string. If it's a valid grade, we're going to take modulo 10, so take the ones digit of the score, And if it's greater than or equal to 7, that's a plus. Less than 3, it's a minus. We're not going to write tests live. I have this beautiful thing of tests here. And for those of you who did want to see how to create a map all in one line, it's not that clean. And this is why I never remember it off the top of my head, because it's a little bit extra stuff. But map.ofEntries instead of arrays.asList, map.ofEntries, and then map.entry as a static method call for each one of your key value pairs. For me, I think it's easier and cleaner just to call map.put every line. This isn't much cleaner than that. But for this case, I did it. And when we're checking for these letter grades, what we would like to do is check every single boundary. We have a lot of, not necessarily edge cases, or literally edge cases, depending on how you look at it, for each boundary. The boundary between every pair of letter grades should be tested on either side of that boundary. And we can get pretty comprehensive with this. These are integers, let's not doubles. Like if they were doubles, how close to the boundaries do we get? At some point, we're going to get truncation errored out, so I don't know. But here we can get pretty good. 100 is an A+. That's the upper bound for grades. A 0 is an F, kind of our edge case, kind of. And then we check every boundary, and I think I did just the boundaries. And for some of them, I do something in between. 99 seems like a special case to me, so I made sure I coded that. 97 is an A+, 96 is an A. I want to check that boundary. When we flip from 96 to 97 and someone earns that next point, their letter grade should go up. I want to make sure my boundaries are exact. Bugging recursive methods. Ooh, baby. Oh, we should do that. Maybe I'll hammer in an example of that today. Yeah. Yes, I don't want to go into it right now, but let me give you a quick answer. Map is the interface. I'm coding to the interface, so if I want to change this, the type of map that I'm using in the future, I can still use this variable of this type, and then change, I forget what of entries even returns, just something that implements map. Immutable map. From a quick look, it looks like it's returning an immutable map, so it's not returning a hash map. So I can't use hash map here. I guess that's my short answer, because this doesn't return a hash map. But if I code to map, and then I do want this to be a hash map later on, if I'm coding to the interface, I'm allowed for that to be a hash map. I can let it be this immutable map. I can swap it out whenever I want to. Is a nice foreshadow of polymorphism way later in the semester. So I'm checking every boundary. I'm not going to go through every single test case, but there's a bunch of them. This is more comprehensive testing. Usually in lecture, if I'm coding up the test cases, I do a couple of them, and I'm like, obviously we would make this a better test suite later on. This is a better test suite. This is solid, possibly just overkill, honestly. But this is solid testing. It's going to give me a lot of bugs identified. And that's our goal for testing. We want to say, if my code has this specific bug, let me write a test case for it to make sure that it doesn't have that bug. So we want to be able to identify every single bug that could possibly happen. What happens through the whole F range? I want test cases all through there to make sure I don't have some weird behavior in my code where like 43 ends up giving an A instead of an F or something like that. And then our invalid grades, a nice random smattering of invalid grades, including min value and max value. Let's test the absolute outer edges of our code to make sure that it works, even with very large or very small values. So this, rock solid test suite, and then I'm iterating through my values, getting the expected, or iterating through my keys, getting the expected as the value, computing the actual, and then I have a nice hint string if my test fails to tell me what's going on if it failed. And I did put everything in one big test method, so maybe I shouldn't have done that. But this is a good amount of test cases. So let's run this and see how our code does. Would you be able to make a while loop to test all the number of grades instead of typing it out one by one? No. I want to say no, but yes, you can, but you shouldn't. You shouldn't do, because what's being suggested, you could go for I equals negative a billion until I less than a billion, or well, I less than a billion, I plus plus, and check every single value. The problem with that is, or hell, min value to max value, though your test is going to take a long time to run. The problem with that is, how are you going to generate the expected? So when you have a value, you're looping through these, you have I stores some input. What's the expected output? How are you going to do that? What you're going to do is write a copy of the method, call it, and make sure the two values are the same. But now you have the same method. You're using your method to generate your expected. And once you're using code to generate your expected, you're not testing anything, because you're going to, if you didn't write this method the right way, you might copy and paste it. Hell, some people might even call the same exact method. Did this method on the same input return the same output both times I called it? That's not testing anything. So we want to hard code the expected for each one, and we want to ideally compute that. I shouldn't even say ideally. We want to compute that outside of our code. If we're writing code to generate our expected values, we're going to make the same mistake twice. If we made a mistake, we're going to do the same thing twice. We're the same person writing the same method. It's not going to work for us. So we're not testing anything if we do that. What I want to do is take this 93, use my human eyeballs, go over to my grading structure, figure out where 93 is. That should be an A. My expected value is A. Now I know that that's a rock-solid test case, and I'm not relying on my coding ability to generate that test case for me. Now I actually have verifiable ground truth to be able to run my code against. And that's what we want. Any way of generating, same thing with random test cases. Some people want to say, give me 1,000 random, when you're testing with doubles especially, give me 1,000 random doubles and run my code on these doubles. Okay, how do you know what the expected values are without running code? That's the same code that you're trying to test. So it gets tricky in that sense. Yeah. All right. Because that is something a lot of people do think that right away, but that's the reason why not to do that. So yeah, this looks like a whole bunch of cut and paste, hard-coded. That's what you want for your test cases. One case where we want to be like that. Okay. Oh, I already ran it. Okay, and we have a bug, because of course we have a bug. And a few things with this. First, we haven't ran the debugger at all yet. Let's run the debugger. So we have a failure, but before we even get into that test case that's failing, let's see what the debugger even is. So to run the debugger, what we're going to do is set a breakpoint. To set a breakpoint, you go over to what we call the gutter. I don't like calling it that, but go over right next to the line numbers. Pick a line where you want to start looking at your code and analyzing your code. Usually, I'll put this at the top of my, you know what, let's do that. Put it at the top of my code. So the very first thing that's going to execute, the very first line of code, the first line in main, the first line in your test case, wherever. And then instead of running our code using the run button, we're going to slide just a little over to the right and click this debug button. And now we're running the debugger. What the debugger does, I've pitched it so much I talked it up, but I didn't even talk about what it does yet. What the debugger does is it will run your code as normal until it hits a breakpoint. So the very first line is a breakpoint. So it fired everything up, got things going, and then immediately stopped because it hit a breakpoint. Once it hits a breakpoint, it stops everything and shows us everything that's in memory. It shows us the stack and the heap and all of the values of all of our variables and all of our objects, and shows us everything that's going on in our code. So I have the stack here. I have a lot of, these are all the stack frames, and the active stack frame is on the top. These stack frames, the ones that are in yellow like this, these are internal to Java. We don't care about those ones. The only one we care about here is the test grade stack frame. So we have a stack frame for test grade. We're currently on line 13 in the test grade method. That's what we're interested in. And then here's the values on the stack, in the stack frame for the grade test method. We have a reference this, which this is a non-static method, so it has to have a reference this, though it's a reference to the grade tests class, which we're not really interested in here, but there's nothing in there. We can look at it, but we're not really interested in that. And then once the debugger stops at a breakpoint, we have there's 5 buttons I always like to point out. Are we going to get to all of them today? Yeah, maybe. But 5 buttons that I really like that are going to be useful. This one, this one, this one, this one, and this one. So let's talk about them. So this is the first one that you want to start with. Step into is going to advance your code by 1 line and show you everything that's going on. So we click step into. This is why I didn't want to start on this line. I'm going to click it again. You know what? Let's set the breakpoint on a different. I want to talk about that, but that shouldn't be the first thing you see when we're talking about debuggers. So I kind of got in a spot that I don't want to be in, so here's a good case to talk about this button, the resume button. My code got into Java code, my debugger got into Java code that I don't want to debug. I don't want to debug Java libraries. I want to debug my code. So I'm setting a breakpoint at a different spot that's later than the one that I had set already. And I want to, I did get rid of it. I got rid of this one. And my code's running. It's going to initialize the map and do all this map.entry stuff. And I don't want to go through all that. I want to go until this breakpoint. So I'm going to click the resume button. And that's going to fire up the code again and run until it hits the next breakpoint. So now I jump right to this next breakpoint. And I can take a look at my test cases. This is storing a reference. This at, if you think of the at as our OX, you'd be doing fine. This at 1187, I have an immutable collection of map n, which we actually saw. Coincidentally, we went into the code and saw where that was being created. And I can click this arrow right here. This is going to say, this is a reference. Take me to the object and show me the instance variables of that object. And it's going to show me everything that's inside this map. I can see all the key value pairs. I can expand these more if I want. The key is 101, value invalid grade. I can see all of my test cases in this hash map on the heap. Then I want to advance 1 line. So step into is going to go 1 line and show me the difference. So I'm iterating over the key set of test cases, and the first key that I got was a grade of 101. Remember, this is a hash map. The order of the keys doesn't really matter to us. We're going to get something as our first test case. We happen to get 101. The way this immutable collection works, if I recall from this last semester, I think we're going to get a different order of test cases every time we run this for reasons. I don't know why. I should have just used the hash map, but it does give me other things that I get to talk about with the debugger. We're going to go step into, and the reason it's called step into is whenever there's a method call that's going to add another stack frame to the stack, it's going to go into that method call. So I'm on this line right now. We're just starting this line, the highlighted line here. Well, this line's highlighted too, but it's highlighted because of the breakpoint. We're going to go into this compute grade method. That's the method call that's about to happen. We're going to get a new stack frame. So stepping into is going to go into the compute grade method, which is going to call the letter method. Let's get a few stack frames on the stack. If you get into a situation like this, I click step into, and there's 2 method calls on the same line. So it's asking me which one I want to go into, and I can click whatever one I want. Or I can click step into again, and it'll choose for me. It'll go into the letter method, and let's click this a few more times to get right here. So we got letter grade and 10s in the stack frame. And right here, I want to show you how to read this output. Now that we have stuff on the stack, let's talk about this thing. So we can look at our stack memory, and we have 3 stack frames that we're interested in. Again, these ones are all internal to the JUnit library. There's a lot of overhead in JUnit before it gets to the point where it actually calls our test. And since we're here, if we go all the way, not going to let me. Anyway, well, we can see the name on the bottom. If we go all the way to the bottom, there actually is a main method in the JUnit library where things started. Every Java program always starts with a main method. It is there. It's just invisible to us. We don't really care about it. And then it calls all this other stuff before it finally gets to our code. But we can go to the stack frames. This is the active stack frame. In the letter method, we have score is 101, letter grade is invalid grade, and tens is 10, or 101 integer division by 10. We can see all our values. So when you're going through your code, you can step through your code and make sure each value at each point in time is what you expect it to be. Without a debugger, this is where we would do print lines. We compute tens, and then system.out.println tens, and just print out all of our values all the time. And we run our program. We get a whole screen full of just garbage dumped out, and we try to make sense of that. Or you can use the debugger and step line by line without ever writing a print statement and see all the same information and more, because you see all the intermediate values, all this good information. And we can go up a stack frame. So this is the active stack frame. It's on the top of the stack. We can go down to compute grade and see what it's doing. It's sitting right here waiting for its letter call to return. And it has a score variable equal to 101. These are static methods, so there's no this in these stack frames, no reference to the calling object because they're static. And we can go down to test grade. This is non-static, so there's this, but it's something we're not really interested in this case. Our test cases and grade, which is currently 101. So we can look through everything to see what's on the stack, and any variable that stores a reference, we can check out what all its values are in the heap. So a lot of information. All of the information that we put on our memory diagrams, which, by the way, memory diagrams are not something we made up just to put you through some torture. It is actually what's going on. This is showing you what's actually going on in memory. In your memory diagram, you are effectively being the debugger and giving us the same information to show that you do know what's happening when your program executes. What is that stuff actually doing? And the debugger is a great way to test your memory diagram knowledge. If I were taking the class, I would take any code, literally any code, do your memory diagram line by line while the debugger's running. Figure out do your memory diagram to see what is going to happen, like guess, well, hopefully not guess, but say what you think is going to happen on the next line, and then tell the debugger to advance one line and see if that's what actually happened. Excellent way to practice memory diagrams, as long as you're, after you get used to reading this output. You have to be able to read this specific format first. Okay, so we got 101. We have this conditional. Score is 101. So this should be false, and it's telling us right here that it's false. And it's telling us exactly what part of it's false. False and, I didn't expect to talk about this right now, but the debugger's putting it in our faces right now. So we have false and you see everything else is grayed out. Once we have an and is only true if both inputs are true. Since the first one's false, what Java's going to do is actually short-circuit the evaluation and not even compute the right-hand side of the operator. So since it's false and anything is false, so it doesn't even compute the other side of the operation. It doesn't evaluate the other operand. So that's why it's grayed out. So we skip everything. We return letter grade of invalid grade. We call plus minus. Modifier is empty string. We have an invalid grade, so we just return empty string. And we have invalid grade and then empty string being concatenated together and returned. So our actual is invalid grade. Our expected is invalid grade. We're going to assert equals invalid grade and invalid grade. Looks like we're doing good here. We're going to go to the next iteration of the loop, and I'm clicking step into every time here. And we get to our next test case of 100. So let's step into compute grade, step into letter, see how we do on this one. So this one is a valid grade. Our tens is 10. If 10's greater than equal to 9, that's going to be true, so we're going to go into this conditional. Letter grade equals A. This is looking pretty good. And then if 10's greater than equal to 8, 10's is 10. That's greater than or equal to 8. So letter grade equals B. 10's is greater than or equal to 7, so letter grade equals C. Tens is greater than or equal to 6, so letter grade is D. And now the student with 100 just failed the course? Oh, crap. And then we're going to go into plus minus. Modulo 10. So modulo 10, ones is going to be 0. This is a valid grade, so we're getting in here. Ones is 0. Well, that's less than 3. Modifier is minus. We expected A plus and we got F minus. Oh, crap. And that's going to certainly fail the test, so we're going to see our failure here. Okay, so I lied, 6 buttons. I'm going to use the stop button. That's going to shut down the debugger. Actually, it looks like I have 2 debuggers running. I'm going to stop the other one too. Oh, because I was running stuff before lecture. Okay, so let's fix this. So what's the fix here? More 115 stuff, so I assume the silence means, come on, it's obviously your else ifs. So let's add else ifs here. We don't want consecutive ifs. We want one if statement that has multiple conditions to it. So let's put our else's in here. Yeah, exactly. A similar example in I can make the F in else. Similar example in 115. But when I first show you the debugger, I don't want to throw too much out there. I'm just trying to show you what all the buttons on the thing do. So we have this, and the other fix we actually had before. If we have this edge case, if score is exactly 100, let's just return plus and shut things down right there. So now I'm feeling good. We fixed some bugs here, and I'm just going to run my tests again and see what we have. And we get another test case, 59 expected F, actual F plus. So we got a modifier on our Fs, and hopefully you see what the issue is. We're going to put a 6 right here. So that's not what I want to focus on. How are we going to find that bug if we don't see the issue? So what I want to do is set my breakpoint to a spot. I want to look for the test case 59, and we can kind of figure that anything from 0 to 60 that shouldn't have a plus or minus, but is in that range where it's going to get a plus or minus is going to do it for us. So I'm going to set a breakpoint here, hit my debug button, and use this resume key. I'm going to hit this until I see a test case that I'm interested in. So the first test case we got, 61. We get random order each time, which I kind of like because I get to say more things about the debugger here. But I'm going to use the resume button. That's going to resume the code until we hit another test case. With 61, I'm pretty confident that we're going to get the right grade, get through this assert equals, and get to the next test case. So I'm going to use resume. 61? Oh, thanks, Nicholas. I was looking at the size of the map. There we go. So 59 is our input. Well, wait, 59, I don't really get to talk about anything. So this button, I get to talk about this button now. Rerun, this just restarts the whole thing. Whenever you change your code, you'll often be doing this. You'll be running the debugger, and you'll change your code while it's running. The debugger is not going to run the new code in the middle of a run. You have to restart the thing. So restart it. I got 51. One that's not interesting. Okay, 101. 101 I'm not interested in, so I'll hit resume. That goes through the loop until we get the next input. 100, that's going to be good too, so I'm going to resume. 99 is fine, 97, 96, 93, 92, 90, 89, a whole bunch, 87, 86. Well, I didn't want this many. We'll get there. 59. Okay, now 59. This is one that I'm interested in. So let's step into. So I got into the letter method, and then I realized, oh crap, I don't want to be in the letter method. So that's where we're going to get one of these other buttons, our second to last one, step out. What step out will do is run until the current stack frame ends. Even if that stack frame created more stack frames, it created more stack frames. It might be a recursive method that goes 100 deep, 100 stack frames deep, doesn't matter. It's going to run until this stack frame that's on top of the stack returns. So I'm going to do step out. That gets me out of that stack frame. Now I'm going to do step in2 to get into plus minus and go through this code. I have this conditional. We're going to get in here. We're going to see that it's going to give me a plus modifier because ones was 9. We can see that ones was, I clicked a little too fast there, but ones is created inside of this conditional. And I'm at this line right here, so the ones variable is no longer in memory. That is an actual thing. That's how things actually work. That ones is no longer in, not just something we do for memory diagrams, but this stack frame, or this code block is crossed out. It's not in memory, and ones is no longer in memory. If it were in memory, we would see that it's 9, greater than or equal to 7. We hit the plus. So let's fix this thing. 60, and then I'm going to hit my rerun. Actually, I want to get out of the debugger at this point and run all of them because we might have all of our tests, and we do. The last thing I want to show over here is I want to break this again. Run our test cases. We are correct on everything now except the value 100. So what we can do to debug this is keep clicking this until we get to 100. Or we can set what's called a conditional breakpoint. If I right-click on my breakpoint, I can set a conditional, and I'm going to do grade equal 100, just like your if statements. Run the debugger again, and now I don't have to do any of that clicking. I'm going to get exactly to the test case that I'm interested in. When you have lots of data, especially when we get to file I/O and you have data structures with tens of thousands of elements, it can be very helpful to set a conditional breakpoint and have it break exactly at the value that you want to check out. Whatever is actually breaking your code, get right to that in one single click. That's something we like to do. And then we would fix our test case. Run our test again. Everything's passing. We're good. We're feeling good about the grades test. That one took a while, but it's because I had to introduce the debugger to begin with. So hopefully we can get some of the juicy bits out of this item class. So I have this item class. Let's talk about what this is supposed to do. Any questions on that, by the way? One button I haven't talked about yet, step over. I hope it comes up naturally, or else I have to just force it in there. Okay, so the item class will have instance variables, description, price, and an array list of doubles, which are sales that are applied to the item. The constructor is going to take 2 instance variables, but not the third one. So don't put sales in your constructor stack frame. Common mistake I always see. A getter for description, a setter for description, a getter for price, which is going to apply the sales to the price. So if I have a sale of 20, that's going to be a 20% sale. If my item is 100, base price 100, and a 20% sale, it's 80, and the sales will compound multiplicatively. So if I have a $100 item, a 20% sale, and a 10% sale, that is going to be an $81 item all set. It's not going to be 71, not 80, 70, I can do this, $71, not $70. So you don't add the 10 and the 20. It has to be multiplicative sales. So we're going to multiply the sales together to get our final price. We're going to round everything to 2 decimal places because we're going to round to the nearest penny. A setter for the base price, a way to add sales to our array list. Computing tax. If we have some tax rate, and this is a rate, not a percentage, so if the tax is 0.1, that's a 10% rate, and I want to multiply that by the price to calculate what the tax on that would be. And a receipt line. This isn't strictly how receipt lines would work, but to get this example to be more interesting, our receipt line is going to print out the description of the item, colon, space, $, and then the total price of the item, including tax. Usually a receipt will have tax at the bottom of the receipt. But for purposes of the example, we're going to put it all in line like that. So there were bugs in there. Did you see them all? Went pretty quick, but the one, yeah, let me just go with it. And we have a whole bunch of tests. I'm not going through all these tests because there's a lot of them. But we're going to run them. I'll go through some of them, especially once we start seeing the ones that are failing. So when we're going through our tests, I ran the test here, and I'm going to take advantage of these icons over here to see which tests are passing and failing. This is green here, so that means this test passed, and I don't have to look in my console, in my output for my testing, and try to match up by the method names. I don't want to do that, so I'm going to scroll through these in order and just look at which ones are passing and failing. So item description, I create an item, I check if the description is what I gave it in the constructor, I call the setter, call the getter again, make sure the description's fine. That one's passing. Description, no bugs. The item price with no sales, so if I create an item for cereal and I want to pay $6.50, better be some good cereal, I'm going to make sure that that's within tolerance, which is 1/10 of a penny of what I expect, which is $6.50, and this one, passing. Item with one sale, passing. Base price of $6.50, so the same cereal, but on sale for a little bit more reasonable price. A 20% sale, I expect that to be $5.20, and I'm going to get the price after adding the sale and assert that my expected and actual are within 1/10 of a penny. Passing, we did good on that one. Test item price with one sale, multiple calls. This is where we start failing, and this is where we can start our debugging. So we have an item that's $100, a sale of 20%. We expect that to be an $80 item. And I like setting my test cases. I always like having at least one test case for each feature that's super straightforward. I can do this math in my head. I don't have to worry about, I punched the buttons in my calculator wrong or anything. I can do this math easy enough, so I know my test case is good. A $100 item that's 20% off should be $80. Easy math. I'm going to create an item, add the sale, get the price, and assert that I did get the price that I expected. And then I'm going to call getPrice again. GetPrice is a getter. Calling this again is going to return the same exact value as it did the first time, and then I'm going to assert that again. This test is failing, so let's get back to the debugger. I'm setting a breakpoint on my first line, hit it with the debugger, and it's going to stop. I'm going to use step into to advance some lines. I can see my variables populated in my stack frame. I'm going to create a new item that's going to go into the constructor. Notice in the constructor stack frame there is no sales variable. That does not go in all instance variables don't automatically go in the constructor stack frame. Only the constructor parameters, description and price in this case, go in there. And then when we run the constructor, it's going to create instance variables. This is a reference to the object being created for all of our values. Right now, they just have the default values because nothing happened yet. But as we go through the code, sales is going to get a new array list of size 0. Description equals description. We can see the instance variable populating on the heap. And then price equals price. The instance variable on the heap got the value of the local variable in the stack frame. And then its returns, we have item at 1248. So item in this stack frame is 1248 with all those values that we expect for that instance variable. So we can watch our references, zip around through memory and watch how everything's working with that. We're going to add a sale, and this is where I'm going to introduce our last button. Adding a sale, I don't really care about. I'm confident that this is working because my other test cases were passing with that involved sales. So for this one, I'm going to use step over. This, instead of advancing exactly one line and going into new stack frames, this is going to advance one line and step over new stack frames and method calls. So I have a method call on this line that I don't really want to look at. It's just adding to an array list. I would find it hard to believe if I had a bug here, but if I don't find the bug, maybe I'll go into it next time. So I'm going to do step over, and that's going to skip that whole stack frame. That stack frame still happened. The code still executed, but I'm just not interested in it. So I told the debugger to not show any of that to me. Just run it and let me know when that method's done. Then I'm going to call getPrice. This one I do want to go into because there's some more logic going on here. It's more than just like add sale was just this line. This is what we skipped. I don't want to debug that because there ain't no bug there. I mean, maybe there could be some cases. So getting the price. I'm going to iterate through all of my sales. There's only one sale. So this, and whenever you see this glasses thing, that means that's not a variable in the stack frame directly. It's just showing you an instance variable, this.sales, that's going to be relevant for the computation that's happening right now. But if you were doing a memory diagram, anything with the glasses next to it, that does not actually go there in your stack frame. It's just the debugger giving you a heads up, like, hey, you don't have to click those arrows. I'll just show you the relevant bits of information here. But we have a sale that's just the 20% sale. So sale is going to be 20. We're going to calculate that sale. So price is now 80. We're going to return 80. We're going to round it. Return 80, so actual, let me compress this. Actual is 80, expected is 80. We're looking good. We're going to call get price again. And now we're going to run this. Our sale is 20%. Our price is 80. We're going to apply the 20% sale, and our salmon just got an extra 20% discount. We're going to return that. Actual is 64, expected was 80. This test fails. What's our issue here? Everyone at once. Our issue is that we're going over to the heap. We're actually changing the instance variable. So we have a reference to an object on the heap, and we changed the value of its instance variable when we asked for its price. Get price should just return the price. It should calculate and return the price. It should not modify the object on the heap. This is a common mistake I see a lot of. Be very careful when you're going over to the heap. Do not change the values of instance variables when you're not supposed to. I mean, obviously, sometimes that's what you want. But in this case, we don't want to. We want to compute the price, and we don't want every time somebody buys salmon at our store to discount it even further until we're basically just giving it away. We don't want that. We don't want that to happen. So we want to make sure we're not modifying the instance variable. For this one in particular, I like to do double, I'll call it price. This dot price. And then instead of modifying the instance variable, we are going to modify this temporary variable that we're creating and return that. So now we're no longer going over to the heap and making changes. We're creating a temporary variable, making changes to that temp variable to apply all the sales, and then returning that variable. This dot price stays the same. We run our debugger again, and I'm going to use step over to get through the stuff that we were already doing. I could just put my breakpoint somewhere else. And now when we get to the second get price, this dot price is unmodified, but we're still going to compute a price of 80. We're still going to get a price of 80, so we're correctly computing this even when we call price multiple times. So be careful with your references. Don't go over to the heap and make changes when you're not supposed to, when you're not expecting to. Okay, let's go back to our tests. Get rid of this breakpoint. That test is passing now. An item with multiple sales, we actually didn't have a bug there, so we did good there. We have two different sales, making sure they compound multiplicatively. Everything was good with that. Did my math right. Feeling good about that. Multiple sales again, did good. Multiple sales, multiple calls, even with multiple sales and multiple calls to get price. We have no bugs in either of those instances. We want to start combining things and having more complex test cases. That one was good. Test item price with multiple sales 3. We got 4 sales. Here's where I like to get more complex with things. Once the easy basic tests passed, I want to really challenge my code and give it the harder test cases. The easy ones are for me to easily debug. The simple, the dumb mistakes, like I went over to the heap and made a change, I want to fix that one. Now I want to make sure that my math holds up under scrutiny. If I have 4 different sales, somebody has a coupon and a bonus card, and there was an outside sale, am I getting the right stuff? And I am. That one's good. Test item tax. I have an item that's $10, 8% tax. That should be 80 cents tax. Compute the tax. It was 80 cents. Passed. Good. Feeling good. And then we get to our next failing one, test item tax with sales. So I have a sale and a tax. I didn't mention this when I was showing the description of the item class, but when we have an item that's on sale and has a tax, we want to pay tax on the sale price. If I have something that's $1,000 and I say 90% off, you get it for $100, and then I say, oh yeah, but there's a 10% tax, so I'm charging $100 extra in tax. No, you pay $10 in tax, not $100. You don't pay tax on the original price, you pay tax on the sale price that you actually paid. So we want to make sure we're computing tax the right way. So if this $20 item is half off and a 10% tax, that should be $1 tax. I paid $10 for this item, 10% tax. That should be a $1 tax on this item. So let's see what we get. I'm going to use this button to run just this test to see what we actually get. Our actual was $2, so it does look like we're doing exactly that, computing the tax on the original price. So let's set our breakpoint right here, run the debugger, get in there. Oops, I did add sale. I want to compute tax. So compute tax, if we look at this method, we're computing on the original price, this dot price. Just do the quick change. I want to change this to get price. Get price is what's applying my sales. So if I call get price, that's going to apply the sales to the base price, and now I have the appropriate sale price in computing tax on the sale price. So I'm feeling good about that one because I want to get to hopefully the last example. I won't really be able to do the last one justice. But the receipt line, our very last method here, is going to, we're expecting, let me do the simpler one here. We have a $5 item, 10% tax. I expect that to be cereal $5.50, and we're getting cereal $5.5, something like that. I don't really have time to do this one justice, but yeah, there's a bug here.